This is a new innovation that vibration research developed for a new method of clipping called TruClip. It's available in the random test mode, and it utilizes closed loop control to reduce high sigma peaks on the shaker table. And we can minimize the chance of exceeding our maximum limits in acceleration, velocity, or displacement. So a bit of background of why this might be necessary. For a random noise test, the amplitude values have a certain probability of occurring at a high sigma level. The higher sigma peaks will have a lower probability of occurring, but they can still be likely over a long duration of test, up to somewhere like 6 times the RMS value. That might only appear much later when running a test. Previously, what was available was voltage clipping, which applied to the output, but that didn't quite translate into acceleration, velocity, or displacement clipping. You wouldn't see the clip appear on the control accel that you are listening to. So TruClip affects the control, acceleration, velocity, and displacement and limits the peak sigma values. And we can apply it when running a test to protect the shaker system or the product when running these long random tests where you're likely to see some high sigma values. And this is just a quick representation of the differences between voltage clipping and acceleration clipping. So on the left column, I have all voltage traces, and on the right, I have all my acceleration data. The top black line is with no clipping, so you can clearly see peaks in both voltage and acceleration exceeding the red line we defined. When we turn voltage clipping on, we see the voltage, this purple trace here on the left, get reduced to that 3 sigma value that we defined. On the acceleration data, we still see those peaks even though voltage clipping was applied. But now with TruClip, we can turn on acceleration clipping. And while we don't see the clipping in the voltage that is coming out of the controller, we can clearly see in the acceleration data that these peaks have been shrunk and reduced. And I can now go into the software to show you how to set up TruClip to run on a random test. You can go New Test, Random, go to Advanced to bring up all of the options in parameters on the Parameters tab. Where sigma clipping is, we now have 3 new options: TruClip acceleration, velocity, and displacement. I select acceleration and hover over the clip above box. We can see that this test requires 1.8 G of could be likely seen with this 6 sigma value. I can lower this to reduce my peaks to 4 sigma, and this combo box will update now to 1.2. And so when I run this test, the peaks above 4 sigma are going to be reduced to that level. Some reasons you might want to do this are, like I said, of wanting to keep these high peaks from tripping out your shaker when you're running close to these shaker limits, or when there is a sensitive product that can be affected by these high peaks that you wouldn't typically expect or typically want to contribute to the overall test. And likewise, the displacement clipping can be done when you're running near the displacement limits of the shaker. And that can be turned on just by selecting the displacement method. And you can see in the tooltip that we also show the inches peak to peak that you expect with this 4 sigma value enforced. And you see our current system limit of the 1/2 inch peak to peak of our shaker that we've configured for here. And also, voltage clipping can be done, and one reason you might want to do that when running a servo hydraulic shaker is to limit and keep it under the maximum flow to help prevent cavitation.